All right, what does addition mean? So let's see. I've got online adding to sums. Okay. Makes things bigger, like 5 + 5 is 10. All right, anybody else? What does addition mean? What do you got?
Addition is the act of combining things primarily worded as such when numbers and representative numerals are involved.
Okay, so we've got keyword combining.
Combining something with the word correct in English.
Yes, right. Yes, we shouldn't use the word we're trying to define in the definition. That's a good point. Combine, we got some. What else?
Putting items together.
Putting things together. Yeah.
I said a number growing from its starting point.
Together. Number. You say growing?
Growing.
Growing.
A little bit would help the exercise, but I know people also thought about synonyms like the word also.
Also.
Usually when you use also as a conjunction, it adds on to your previous statement.
That's true. Yes, also is right. It's an addition in that way with words. Yes, I was talking to I teach an intro to programming class, and there's another term for that in programming language called concatenate, which just means put together. Like you concatenate words to make a sentence. All right, so two things that I really like here. Oops, I want a highlighter. Combine, that's a good one, because combine feels physical to me, right? And put together, that's totally physical. And when we're talking about what things mean before, often if we don't have the right connection to other words with people, then the only way you can explain what something means is to show somebody, right? So with addition, it's very important that we're able to show what addition means. Words like some are okay, but what does some mean? Now, what's that? It means to add, right? Yeah, so then we make this loop. Now, technically, the sum is the result of doing an addition, but it's really just another word that means addition. Now, combine and put together, though, aren't quite enough. Can you read me again what you had, Matt?
I wrote, addition is the act of combining things primarily worded as such when numbers and representative numerals are involved.
Yes, okay. Now, number versus numeral, we talked about that one last time. So I'm just going to make a minor alteration here, Sid. Instead of a number growing, maybe how about an amount?
I was gonna say value.
Value would be good, yeah. So, but they all mean amount, number, value. They all mean the same thing when we come down to it. So I don't know why I thought amount would be better, because like we talked about last class, they all mean the same thing.
Right.
So either one of those is good, but the physical is important here. So what does it physically mean?
So when you told me that you guys were thinking on this,
Yeah.
my first thought was, oh, okay, well, you're not always going to add a number. You could be putting shapes together. You could be putting.
There's lots of things you can put together.
Liquid together.
Oh,
so
yeah.
I was like, okay, so I was just like, what does the word addition?
So yeah,
so I went off just.
So that means combine and put together are still not enough. That's still not quite what addition means. So there's one thing I heard from someone, it might have been you just now, we need to add to either combine or put together to make this right.
I was thinking actually what she said, putting together an amount that grows. Okay, what is it? How do you know what it grows to? From its starting point.
Yeah, how do you know what it grows to?
Whatever you add.
So if we want to illustrate something like, let's say 4 + 3.
It grew by 3.
What does it mean to grow by 3?
The difference between its starting point and its ending point.
Okay, so what's the answer? Why? How do you know it's 7?
Because it grew by 3.
How did you get from 4 to 7? How did you get from 4 to 7?
Counted.
You counted. Holy crap. That's the connection. Yeah, it's not just to put together, you got to count it. Otherwise, it's just this memory. Like you guys have this memory,
right.
But when kids are new at this, what are they going to do? They're going to hold the things in front of them, or they're going to hold up their fingers, and they're going to go 4, 5, 6, 7. Oh, I do too. I still count on my fingers. So So let's put it together. What does addition mean? I'm going to go with put together and count. Because if we don't count it, then all we've done is put stuff together. We don't have a sum. And the sum is the result of an addition problem. So just some terminology here. The 4 and the 3 are called addends. So 4 is an addend, 3 is also an addend. And 7 is the sum. The result of combining and counting. Yeah, probably not. Yeah, I know. I only hear them when I teach this part of the class. So if I really want to show 4 plus 3, then I have to show 4 things, and maybe there are 4 shapes. These are the best squares I can draw today. So I have 4 things, and then I want to combine, or maybe take a union with 3 things. And when I put them together, they combine to 7 things. And I mentioned an idea last week called subitizing. That's when we look at a group and we're pretty good at recognizing, oh yeah, that's 5. Without specifically counting 1, 2, 3, 4, 5, we just know that looks like 5 to me. And that intuition on amount is called, psychologists call it subitizing. And since our number system is based on 10 and humans aren't good at recognizing without counting 10 things at once, it's helpful to, when you combine things like this for young kids, to group by 5 and then put whatever extra goes next to it to have an organized chunk of it. It's similar but different from the way we put numbers on a die. They're not random, they're grouped, so they're easily recognizable. And when it's a good idea when grouping numbers as things for young kids, if it's over 5, then have 5 together clearly, and then whatever goes next to it is nice. And there's a set of toys that a lot of classrooms have. Oh, I forgot what they're called, but they have groups of 5 all over the place in them. It'll come to me before the end of class what they're called. All right, so addition means combine and count. Great. Kids do it over and over again, and then they get this recognition. Like they don't have to count 4 plus 3 anymore. They just remember it's 7. Okay, and most of us are like that for a lot of sums, but every once in a while, how many of us still count on our fingers? Me, right? It's okay. It's natural. It's what we do. So then the problem is once we get the basic definition, and by the way, the basic physical definition here, this is called a model. So we have a model for the addition of whole numbers. Oops, wrong button. Model for addition of whole numbers. This model is called the set model. And the model is simply to combine sets and count. As in that example we just saw. And the sets could be anything. They could be sets of toys, sets of blocks, sets of fruit. Now there's a slight variation on the set model called the number line model. For addition. And that's simply where we have a number line or a ruler where we clearly mark off whole numbers, starting with 0. Spaced if possible. And so on. So a lot of times kids' desks will have a ruler that has their name on it, maybe that's in plastic or something. And with the number line model, there's one of 2 ways to look at it. For example, to demonstrate 4 plus 3, we would draw a length of 4 and then combine that front to end with a length of 3 and see where we get. The other way is just kind of skip counting on the number line, where we just go to the number line, either draw or point 1, 2, 3, 4, 1, 2, 3, and boom, we get our answer. So this is kind of like what we call skip counting. So again, the set model is where we have a set of 4 and a set of 3, and we put them together. And they could be sets of anything. The number line model is a little more specific, where we're playing with a ruler or a number line and demonstrating how to get the sum. And either way, it's a combine in a count. It's just 2 different physical representations of it. And instead of combine, we said put together. That's a synonymous phrase to combine. But again, a model has to be something I can physically show you, so that after you see it, we can always agree on what the sum is going to be, right? And the sum is the result. So we get the basic idea of what it means, combine and count, but then we got to figure out how to do it for bigger numbers, and that's when we need what's called an algorithm. And for the algorithms, that's where the toys come in. So if you don't have any toys at the moment, you're going to do one of 2 things. You're going to grab some toys here. And if you're online, you can check out the link we put in the chat. Or if you're looking at this in the future, there should be a link in the video description. All right, so I'm going to do my best drawing of this. It's my best 10 piece. Fine with 17. And then I put them together. And I clearly have got 2 10s there. And I got a whole bunch of 1s. Sloppy there. 2, 3, 4, 5, and then 7. 1, 2, 3, 4, 5, 6, 7. So altogether I have 10, 20, 32. But my illustration doesn't quite show 32 like I'd like it to. What should I do? Yeah, I should trade, like, as if they were, say, pennies for a dime or dimes for $1. I should trade 10 1s for 1 10. And so a better answer would be to show 3 10s. And then there's my 2 1s. All right, so sometimes it's a bit more work, and that trading is a big deal, but I think it's pretty necessary. And if we think about our stacking, let's see, with 15 plus 17, we add the 1s first, right? What's 5 plus 7? 12. Okay, and then that's not really 1 plus 1, it's 10 plus 10, which is really 20. So altogether, I have 3 10s and 2 1s. And this step, how many people thought this is odd? What is he doing? Anyone think that? No?
So I teach in elementary school.
Yeah, that's a pretty common thing kids will do because they did a ton of single digit addition that sometimes with a 2-digit number. And then all of a sudden we start giving them 2-digit numbers to add. And sometimes there's an extra group of 10 and it just is natural for them to put it down there at first. Now we teach a different way to do it often, not everywhere, but often. So just a note on that, when I write it this way and I write the ones without carrying, this is called expanded addition. Where you add the ones and you don't worry about if there's more than 10 of them, you just write the result down. And then you add the tens thinking as tens. 10 plus 10 is 20, right? So again, my thought process on that, 15 plus 17 is 5 and 7 is 12. So I just write 12, lining things up. And then I don't think about this as 1 plus 1. I think about this as 10 plus 10 is 20. And then I clean things up, 2 1s, 3 10s, the answer's got to be 32. Okay, and again, that process is called the expanded addition algorithm. And we have all kinds of algorithms for addition. Now, normally we would write that, well, I guess this is normal in the US, but it's not normal around the world. We have what's called the carrying algorithm. Or something, wrong digit, 15 plus 17, where we train kids to say 5 plus 7 is 12, but we carry the 1, the 10 of the 12 up, 110, put the 2 1s down there, and then we have 1, 2, 3 10s for 3 10s. Often instead of calling it carrying, because that's just the physical act of putting the 1 there, we're really regrouping 1s as 10s. So this is often, instead of called carrying, it's called regrouping algorithm. Now, I mentioned the other day that, we normally read left to right, but we write our numbers right to left, which is because we got it from societies who actually read right to left instead of left to right. Well, it turns out some of those societies also do the addition different. So there are many countries in which for the 15 plus 17, what they would do is they would say 10 plus 10 is 20, and they would just put a 2 there. And then they would come over to the next column and say 5 plus 7 is 12. They would put the 2 1s here and then strike that and put a 3. This is called Hindu addition. Like our number system is the Hindu Arabic number system. Oops, addition.
Doesn't look that different from the way we did that.
Yeah, it's just a little bit different. So they go left to right and their carrying goes down instead of up. So let's try that on a bigger number problem, the Hindu one. Let's try 356. Oops. 56, there we go. Plus 475. What would this look like? So again, they're going to work, if we're doing the Hindu here, we would say 300 plus 400 is 700, and we would just put the 7 in the hundreds column. And then they go over to the next column. So I'm going to switch color. And they would say 50 plus 70. They might even think 5 plus 7 is 12. And they're going to take the 2 in its column where it belongs. And then the basically 10 10s is going to jump over here. They're going to strike that and make it 800. And then similar here, 5 and 6 is 11, which is a 1 and a 10. And that's the way they would write that addition problem. Left to right, carry down.
Solving it, but I don't like how it sits when it's finished, how it's not all right next to each other.
I get you. Yeah, that they're not right next to each other, but
I wouldn't be surprised if it
That's the way they-
just because it's easier to see the answer for whoever's teaching or whoever just needs the information, final answer.
Yeah, that's the way they write it down.
I think it's actually
And-
easier to do it that way, but
I-
it does look a lot more cluttered.
It's certainly different from what we write. And they would look at what we write and they're like, why would you put the number above? Shouldn't all the sums go below? They would just be dumbfounded by the way we write it. Here's a really cute method I love. So this is called the lattice algorithm for addition. And so what was that? 356 plus 475. So what they do underneath with the lattice algorithm is they actually draw in columns for the answer below, and they turn this into a grid. And then they make diagonals from the upper right to the lower left for each of those.
It was too low, so it ends up when you put all the sums at the bottom, but it stays clean.
Yeah. So, and it doesn't matter where you start this. I'm going to start on the right. So 6 plus 5 is 11. And so you would write the 11 like that with the slash separating the 10s from the 1s. 5 and 7 would be 12. 3 and 4 is 7. That just goes there. And then what you have are these diagonals to follow. So in this diagonal here, we have 7 and 1 is 8. 1 and 2 is 3. Oops. Oh. Yep. And there's just a 1 there. So there's the answer. I think that's cute. That's my favorite addition algorithm. Well, the only one is right here because the other side of the diagonal are the 10s. Yeah. And yeah, so it just, there's this nice flow with the diagonals. And it just happens there's only one digit in that first diagonal. There's only one cell in there. Yeah, and had the, had the hundreds been a 2-digit number, that we would have had a number coming down that way. Right? So it's a pretty fun way. Your carrying doesn't get messed up at all, and it just flows really nice.